Alright guys, this is graphing with Ratey day 2. So these are going to be a little bit tougher, and we're going to introduce one more thing that you need to know about these graphs that is not part of the Ratey acronym. There's a sixth letter that doesn't really fit in, but we'll see that in a couple of problems. Alright, so let's just get to it. Hopefully you remember Ratey from our last lesson. So you know that R is for roots, and to get the roots we set the numerator equal to 0. And so we get x equals 1. And we write our roots as a point, 1, 0. All right, asymptotes we get from the denominator. I like to do factoring on the denominator when possible. So this denominator does factor. It's a difference of squares, x plus 2, x minus 2. So we're going to get two asymptotes, very similar to our last example from Ratey day 1. X equals -2 is one of them, and x equals +2 is the other. All right, togetherness, remember we have to have a perfect square in the denominator, and although there is a squared, it's not a perfect square because we got two different factors, so there is no togetherness here. All right, in behavior, that's our three categories: top heavy, bottom heavy, balanced. So this one, we look at our exponents to determine that, and this one is bottom heavy because the exponent on the bottom is bigger than the exponent on the top. And bottom heavy is the easy one. That is when we automatically get y is equal to 0. All right, last step's going to be to get our y-intercept. So we just plug in 0 for the x's, 0 minus 1 over 0 minus 4, and that reduces to 1/4. So 0, 1/4. All right, time to put all this on the graph over here. So we have our 1, 0 root. Our x equals 2 asymptote, and our x equals -2 asymptote. All right, y equals 0, the x-axis is an asymptote, and 0, 1/4, which will be just a little above there. All right, so this one is going to be a little different than our number 6 from day 1 because we are actually going to have to pass through our asymptote here. Since we have a root on the asymptote, you'll remember from that other example on day 1, it was like number 4 maybe, where we bubbled up through and went on the top side, so something similar is going to happen here. All right, so I know that this side, this has to go this way because it has to also go through our y-intercept there. So I'm going to follow along this asymptote here. I'm going to pass through my y-intercept and then hit that root. Okay, and then once you hit the root, you've gone through the asymptote now, so the only option is for it to just continue going down, and it's going to approach this asymptote on this side. So it kind of looks like a cubic graph through there, like that. If there was no root there, then we would have passed through the y-intercept and it would have turned around and gone back up. That's what we saw in number 6. All right, but with the root there, it has to go through that root, and then it just has to follow down. That's the only option. All right, there's no togetherness, so neither one of our other two curves should be right next to the one in the middle. So this one has to go in the bottom, so it is not right next to that one on the top. All right, this one has to go on the top, so it's not right next to this one in the middle there. There you go. All right, number 2. Okay, so remember when we don't have an x in the numerator, we don't have a root. So just none for our roots there. Asymptotes, we're going to have 2 of them, x equals 4 and x equals -1. Togetherness, we have a yes this time. All right, notice the x minus 4 has a squared on it. That's a perfect square. So we're going to say yes at x equals +4. All right, notice the x plus 1 does not have a squared on it. So we have one asymptote that does have togetherness and another asymptote that does not. All right, so we're going to make sure to label that when we graph it over here. All right, end behavior, remember if there's no x on top, that has a degree of 0. And then this has a degree of 3 down here. This is an x squared and times another x. So definitely bottom heavy here, 0, less than 3. So we get y equals 0 as our horizontal asymptote. And finally, for our y-intercept, y equals -3 over 0 minus 4 squared times 0 plus 1. All right, so it's going to be negative 3 over, this is negative 4 squared is 16 times 1 is 16. So 0 comma negative 3/16. All right, so let's put this stuff on our graph over here. So we've got x equals negative 1 as an asymptote. X equals 4. And then remember, x equals 4 has a togetherness there, so I'm going to put a t above that one. Y equals 0, our x-axis, horizontal asymptote. And 0 and negative 3/16, which is about a fourth, a little less. All right, so this one in the middle I know has to go down here, and there's no root this time, so I'm not going to cross through the asymptote like I did last time. So I'm going to follow along here. I'm going to hit that y-intercept, but then the asymptote's going to push me back down, going that way. All right, so on the left side, there is no togetherness. So I should not go on the bottom because that'd be right next to this. I should go on the top there. But on the right side, there is togetherness. So I do want to go on the bottom right next to this one. All right, number 3. This is going to introduce that third, that new thing that I did not talk about in our last lesson because we didn't have any problems that did this. All right, so first thing we want to do here is factor. So let's factor this denominator, x plus 1 and x minus 3. And what you're going to see here is that the x minus 3's are going to cancel out. So nothing left on top, not really nothing, it's a 1 on top, and then an x plus 1 on the bottom. All right, but anytime you cross something out like this, you're creating this special thing on the graph. It's called a hole. Well, the official word is that it's a removable discontinuity, but the way that we show it on the graph is by drawing an open circle, and so we call it a hole. So whenever you cross something out like this, you're going to add a 6th letter on the bottom, an H. H for hole. All right, so when we find our stuff here for Ratey, we're looking at the reduced form. That's how we're determining all of this. All right, so for my R, I don't have one because I just have a 1 on top. No x on top. Asymptotes, x equals negative 1. That's what makes my denominator 0. Togetherness, no. No perfect squares. In behavior, it's bottom heavy. 1 is bigger than 0, so bottom heavy. Automatically y equals 0. And then y-intercept, y equals 1 over 0 plus 1, which is 1. So 0 comma 1. All right, so this hole. This comes from crossing out the x minus 3's. So the way you find where the hole is located is by setting that thing you crossed out equal to 0. So we set x minus 3 equal to 0, and we get x equals 3. But if we're going to graph this, we need a y value as well. So the way we get the y value is by plugging in our x value into the reduced equation. So y equals 1 over 3 plus 1, which is 1/4. So my hole is a point on the graph. It's located at 3 comma 1/4. All right, let's put all this on our graph over here. So we've got asymptote, x equals negative 1. Horizontal asymptote, y equals 0. Y-intercept at 0, 1. And hole at 3 and 1/4. Since it's a hole, make sure you make it an open circle at 3 1/4. All right, so one of my curves has to be in this top left quadrant. I'm going to go through my y-intercept and my hole. And no togetherness means my other one will have to go in this bottom left quadrant. All right, so sometimes you'll get problems like this that have a hole, but it actually creates an entirely different graph. So we're not even going to have a rational graph on this one. So you want to start out by doing some factoring. So x minus 3 and x minus 1. And you'll see the x minus 1s will cancel. So we still have the x minus 3 on top, but we just have a 1 on the bottom. So I don't even have to write it. It's just x minus 3. That's the whole thing. This is not a rational function. This is a linear function. So whenever you get the thing left over is on the top, then you don't need to do Ratey. The only reason we do Ratey is because it's a convenient way to find important points on a rational graph. But if you don't have a rational graph, we have other methods to graph this. All right. What you do need to do still is the whole. So I still need to find my whole. So I'm going to take that thing I crossed out, set it equal to 0. That gives me x equals 1. And then I'm going to plug that into my reduced equation. So 1 minus 3, and that gives me negative 2. So my whole is located at 1, negative 2. So let's go ahead and graph that. Open circle there. Okay, and then with linear functions, we plot our y-intercept, negative 3. And then we use our slope, which is 1, as our rise over run. 1 over 1. And look at that, end up right there where the hole is. Let's do a couple more points. 1 over 1 right there. And 1 over 1 there. I think that's good. Draw our line. Something approximating what a line looks like that. Okay, so if you get the 1 left over on the top, it's going to end up being just a linear function most of the time, and you still have that hole there that you have to look for. All right, number 5. Okay, so this one we have to do some factoring, but it's a little different style factoring. We're not going to have the 2 parentheses. All we have is a GCF. So this one we can take out an x, leaving us with x minus 5. This one we can also take out an x, leaving us with x plus 2. Those x's will cancel out, and so we end up with x minus 5 over x plus 2. All right, so we still have a rational function, so we're still going to do Ratey. We also cross something out, so we're going to have a hole in our graph at that location. All right, so for our root, we have x equals 5. So 5 comma 0. That's what makes the numerator 0. For our asymptote, x equals negative 2. That's what makes the denominator 0. Togetherness, no. No perfect squares anywhere. In behavior, this one's balanced, right? 1 and 1. And so when it's balanced, we divide the coefficients in front of those variables, which are also 1 and 1. So we end up with y equals 1 as our horizontal asymptote. Finally, our y-intercept, y equals 0 minus 5 over 0 plus 2, which is negative 5 halves. So 0 comma negative 5 halves. And don't forget your whole. So that thing we crossed out is an x. So we just set x equal to 0, and there's nothing to solve. That's the x-coordinate. So it actually turns out that our whole is the y-intercept, because y-intercepts are where x equals 0. All right, so just when we graph our y-intercept at negative 2.5, we're going to make it an open circle instead of a closed circle. All right, we have our root at 5, 0. I have my horizontal asymptote at y equals 1. I have my vertical asymptote at x equals negative 2. All right, so one of my curves has to be in this bottom right quadrant because it's going to go through my hole and through my root, like that. And no togetherness means my other one will have to go in this top left quadrant. All right, so that's all I have time for in this video. You'll have to tune in to part 2 video to see number 6. But you should have a pretty good idea now of how these work and all the ins and outs. So I'll see you next time.